everyone. It is Mike Levin on Sunday, March 27th, 2022. On my way back, I'm dropping off the kid. Just about to hop onto the New Jersey Turnpike. Still on the first leg of what is about an hour and a half drive. And I do some of my best YouTubing, vlogging. I've received some feedback from people, some gratitude, and you're welcome. I really enjoy making these driving videos. I think it's a testament, it's a celebration of being human, that we are evolved to multitask in certain ways. I wouldn't be doing this if I wasn't giving 100% of the types of resources that require attention to driving. That's the statement. I wouldn't be doing this if I wasn't giving 100% of the resources required to driving, right? Exactly. And so I do take long pauses sometimes as I am merging onto I-95 North. That is an opportune and the quintessential example of a moment which, even while you're vlogging while driving, you do take a moment. Eventually, because the merge isn't even here yet. They give you so much time for the merge. Yeah, so this is one of those tasks that the AIs will be taking over from us just as soon as they're fully capable of doing it as well as humans are. And then there's going to be a crossover point where they're going to be so much better at driving that we'll hardly be able to look back on these days and you were like, wait, what? You had, monkeys, who get all verklempt emotionally at things they can't control in their body regularly today, at the wheel of a clump of metal being driven on the power of explosions hurling across the surface of the earth on spinning wheels, relying on the force of friction, and having no automatic regulation to the whole thing beyond maybe anti-lock brake systems, right? Where would computers step in to help us? Yeah, the ABS. If you had to slam on your brakes, it would make sure they don't lock up. And that's about the most you can hope for. The rest is just human ability. Monkeys are good at this. So, yeah, I'll use the cringy terminology. I am not suspicious. Talking about it out loud does not change the statistical likelihood of shit going wrong or not. It just doesn't work that way. That's called superstition. So, at such a point as this, I would like to throw my hat into the ring of having systems by which you maintain in touch with your animal self, yet rational control of your body. There's a part of you as a being that is working on a purely animalistic level. It, through years of experience and muscle memory, knows how to drive. It knows how to scan the environment, how to look, how to leave following distances and buffers both in front and behind you. You have a 3D map in your head, a copy of reality, and you see very well where you fit in. So long as you maintain a consistent speed with this much distance around you, you're safe. You have to start to worry when one or more vehicles start encroaching on your space, where a lane change would make you both occupy the same space. Then your whole head is in the game. But until that kind of collision detection is sensed, you can formulate a thought or two even while you're driving, especially about the thought or two a self-driving system actually has to have in order for all this to go down well. Put in a destination site, say go, and sit back and relax while a computer does all the driving at these speeds? Really? Well, the answer is going to be, oh yeah, of course. It could not be any other way. In a few years, 20 years, it's always 20 years away, 20 years for fusion, 20 years for, you know, your chimp robot running errands for you type of AI. Neural nets. The elimination of the traditional CPU-bound architecture, you know, yield central processor days, of which modern even ARM architectures are a part. It's, you know, the whole old Mac and Amiga tradition of Motorola 6800, 68000, and then that became the Cell, I think they called it the Cell processor, and PowerPC for sure. But that whole schism has sort of diminished as more people went on to x86 style, Intel style processors for the best economies of scale. And then this crazy miraculous thing happened as manufacturing got down to the 5 nanometer scale. Intel could no longer deliver the goods. Apple started cutting their ties to Intel. The Intel, you know, based processors could not deliver a energy efficient footprint on tablet type devices as well as ARM architecture could. And with everything being able to virtualize and emulate everything else, if that's the case, then why not just move to the one that's more memory efficient? Not memory efficient, but energy efficient. It runs cooler, consumes less energy, batteries last longer. It's a better metal to value ratio. How much metal are you going to put down onto the integrated circuits, right? How complex are your chips going to be? Thus, how expensive, and how directly is that going to be reflected in the quality of your product? Apple knows how to tweak that out, and Apple was about the only platform that had that tweaked out, and about the only company that I saw that had the full skill set to turn that into, you know, an almost totally vertically integrated product. Just a little intellectual property being licensed from ARM, from the ARM processors, of which Apple's implementation is a custom design. They're only, I believe, licensing the machine instruction set, not how you get there, such as it were. So Apple has its own CPU architecture based on the ARM lineage now, to which their Macs have switched over or are transitioning over to. All of their iOS hardware, of course, has been on for quite a long time, and that's going to be their new main hardware platform. And in all but, I guess, the most high-end Mac server, if there is such a thing, cases, it will no longer be x86 or Intel hardware. I believe Apple parted ways at around one of the bridges, the Ivy Bridge or Sandy Bridge, but it's about at the same time as Intel started including their managed operating system, their little copy of Minix, their little copy of Unix called Minix. It's a microkernel design Unix. It was the counterpart, the opposing camp to Linux growing up, as Linus Torvalds was in electronic communication with other people. One of them was Andrew Tannenbaum, who said, no, you don't want a monolithic kernel. Monolithic kernels take on too much responsibility for a one tightly coupled thing. You can't swap parts out and have different, user space versus processor space as discrete things. Now, I think they managed to do that even with the monolithic kernel. They're still user space, so they got some of the advantages of microkernel, but Linux has never been a full commitment to the microkernel design, so the competing camp never really got a foothold, never got an outlet for catching on until about 10 years ago when it started shipping as the shadow operating system with every Intel chip for about the last 10 years on everything in the bridge tradition, the Sandy Bridge and such. Processors have the management operating system, which is Minix 3, Andrew Tannenbaum's Minix operating system, that has a tiny, 1 megabyte footprint, probably if even that, but a full network stack. So your hardware can be communicated to on a full network stack side channel that you have no idea about. It's probably got its own, MAC address and access to whatever, unique hardware identifier, IEMI ID is in the device. So it's a way to call back to mama, That's just the way hardware is these days. But you got to know about it, and you're better off knowing a little bit of Unix and Linux than not, I'll tell you that. One of the recurring themes over the past week or so that I feel like talking about, it kind of fits in on the professional front, is APIs, application program interfaces. That there is nothing but interfaces, right? There's a deep philosophical foundation to the discussion of APIs in computer science and Python, right? There's a lot of different APIs in Python. There's a blending of different APIs, and new APIs get blended in. List comprehensions is its whole own sub-language with its own interface to generally lists as expressed through brackets. So list comprehensions is a way to do something on each element of a list so that it can be expressed without having to write a for loop, right? So for loops are another API. And for iteming collection, and then having the reference to item sequentially each member of stepping through each member of a collection. These are APIs and models, designs, if you will, mental models, and expected interfaces to those mental models on which you can build solutions. So, nonetheless, you've got the interaction between objects, right? Objects, words are funny. You gotta slap a word onto the concept. You gotta give a thing a label. All tools are flawed, but we must choose the flaws we wish to live with. So over the past week, the question of interfaces came up over and over, in that everything GUI, everything graphical user interface, is an API. The API is the graphical user interface. It's intended for interaction with humans. It's a human function, human object interface, point, click, drag, double click, see a little picture of a thing that represents an object. The way FreeCAD works. So FreeCAD has been the big doorway into the more abstract world in which I live for data. In the field of SEO, I use Python, pandas, list tuples and DICTs, sometimes a name tuple. occasionally an ordered DICT, very frequently a persistent DICT, through the built-in SQLite given a new API through SQLite DICT, which you must pip install. The fact you must pip install SQLite DICT is, in my mind, in about the same category that you must still pip install requests, or more frequently now for me, HTTPX, because concurrency. Kenneth writes, apparently distracted. Good for him. Live life. Async await, async IO, incorporated into requests properly for concurrency, not happening. We all love the API for humans, that is import requests. So what now? Well, what now is pip install HTTPX. HTTPX API compatible with requests. However, with a async gather splatting input from a list comprehension that contains a function or an HTTPX get can share session. Interesting stuff. Concurrent HTTP calls, concurrent function invocations, popping tuples off the list into a function that knows the tuple it's about to receive popped off that list. You know, the Pez pellets fit the dispensers. Concurrency, finally grockable. It's all MapReduce. MapReduce locally for fun. If multi-processor, then Dask. Use Dask objects instead of built-in for NumPy arrays, I think. Anything list comprehension. And it will parallelize over your processor. So, Python play parallel, like Go. And Erlang, the great unsung Erlang. Lots of interesting languages, no more than one, but 80-20 rule. Oh, liking the 80-20 rule. It's an excuse for half-assed work. No. First pass half-assed. Only first pass half-assed. Then refined meticulously, because divide by 2, same 80-20 rule pass in multiple successions, very accurate and precise. It's calculus. Diminishing returns, move on. Rabbit holes to be avoided. Rabbit holes to be identified early. Always know a rabbit hole before, while, and during being effed by it. And that's gonna happen. Rabbit holes will happen. You're usually better off for it. Miscalculations in time required for projects. Because rabbit holes, you don't think they're deep, but they're entire wonderlands, new languages to be discovered in some. Sublanguages, everything's a sublanguage, everything's an API that's kind of fit in where the language can accommodate it. So list comprehensions, because Python so far did not preclude it. It fits. Lambda's the same thing. Really arbitrary words. Lambda X colon something with X. It could have been foo X something with X. And maybe it should have been. Foo would have made more sense to me. Foo is an anonymous function. More than lambda, really? Ugh. So, Python has some rough edges, but explicit is better than implicit. So, colon at the end of a line before a block of indented text that is grouped together because white space matters. Honestly, this is going to be done whether the white space matters or not. So why not make it matter? and get enforcement, get explicitness without curly brace tokens. Curly brace tokens and other ways of opening and closing blocks stupid because indent's already explicit. Indent's very explicit. If any question, colon at the end of the def or for or while line, a few things can begin a line that's about, can begin a block that's about to be indented with the context manager. One of the best APIs that got blended in with and then some sort of open operation. And I tell you that with SQLite DICT, Python dictionaries can become persistent. So one must pip install SQLite DICT, and then I rename things on the import. So I go from SQLite DICT, import SQLite DICT as SQL DICT, because it should be reminding you every time you look at it as you invoke it with the context manager as you do. So it goes with SQL DICT database name, some arbitrary file name .db in singular double quotes and inside parentheses after the SQL DICT function. Now, and then space as. It's important to say space as because you've got to give it a file handle. What I, with a context manager, have become used to thinking of as a handle to a physical device. But in this case, it's convenient to think of that physical device as a database. So instead of as FH is my traditional letters after with open or with SQL DICT, it's good. My traditional with SQL DICT is as DB, as DB. Now you've got a DB database file handle that you use the square brackets with and a key name inside of it. And you see that key name is the key of a key value pair or the name of a name value pair, whatever have you. There's different ways to talk about hashes. You know, what is it? Is it key value? Is it name value? There's even other ways to, you know, to talk about it. It's just a 2-column addressing system where the first column is really the addressing system because the first column has all the performance optimizations for lookup done to it. The techniques of hashing are applied to the key so that you can look things up amongst billions of key value pairs and it'll still seem fast on modern computers. So dictionaries are really good. They're really, really useful. And when they're not forgotten between invocations of your Python scripts, between Jupyter Notebook sessions of your notebook, or between runs of your .py file, Python space file name .py, that'll run that as Python code. And when values get set inside that run, wouldn't it be nice if the values that it was working on were available again the next time it was run, so it can remember where it left off, so it can have persistence in memory. Well, to have persistence in memory without having to do all kinds of complex pickling and shelving and other kinds of, like, quote, manual file I/O or weird API, because pickles, you know, loads and dumps and loads, and it's just not intuitive. However, the context manager is very intuitive because things are open with a with whatever. So with SQL DICT file name as DB colon. Now within that indent, you can use DB with square brackets and do key value things. And whenever you do a db.commit, it commits it to the drive. So you can do things in memory in the, you know, synchronized but not committed copy of things, because in the end it's just a very reductionist ORM, an object relational map. It's an object relational map with the simplest object relation chosen, that of a key value pair, a single entity relationship. So it's a really good building block for things. And when you have to do a bunch of API calls, for example, you can use the very same URLs that did the API call as the keys in the key value pair. So it can be DB open square bracket, the URL that made the API call equals the result of the API call, which until that moment was only in computer memory. Got to commit it to hard drive, db.commit. After making that key value assignment, db.commit writes it to the drive. That .db file on the drive now contains that value for that key, and you can get it again. It's a lot like pickling. Like, honestly, you should learn the pickle API as well, because I demonstrated earlier this week when someone said to me, "What's pickle?" When we looked inside the things you could do easily with a data frame, to CSV, to records, and it can do a lot of neat tricks that are built in. And they saw to pickle, and I said to her, well, that probably just writes out an object, a serialized object to memory, so it can reinstantiate an exact copy of that object in memory without having to go through the whole rigmarole of whatever it is that created that data frame in the first place. Let me show you. So I did df.to_pickle, and then I just chose an arbitrary local name. Of course, it's a string, so it has to be in single or double quotes, but, df.pkl. Shift enter. Boom! df.pkl sitting on the hard drive. And I'm like, watch this now. Restart kernel and clear all outputs. Go to a new cell. Import pandas as PD. Let's see, oh no, I probably didn't need to load pandas to do this. You're just unpickling. So you import pickle. And then you do, I believe, pickle.loads. Is it a string or pickle.load? Because it's a binary. It's a little bit of weirdness that you gotta keep in mind there, because there's load versus loads and dump versus dumps. Dump will dump a binary serialization, and dumps will dump a string or a, kind of bin hex. They brought down to probably the ASCII 256 set of characters, so that it'll survive its journey through almost any tech you put it on, because everything can display and record ASCII text. It's Unicode that has difficulty sometimes. So I guess I pickle.load df.pkl, and bam, I've got the data frame back in memory. Maybe I did have to load pandas to have the knowledge of what a data frame was. I'll have to check that. That's an interesting question. So these are the drives with me. Learn to think Pythonically. Pythonically is not everything you'll encounter. There is more than thinking Pythonically you'll encounter in the course of your Python career. One of them is thinking panda, thinking in pandas. Many people pick Python purely for pandas. Many people don't go beyond Pandas API. Pandas API does magical looping things with one-liners. In Pandas, things should only be done in one-liners to be done correctly, because .method something anticipated. Almost everything anticipated, almost everything optimized and internal inside the object of usually the data frame. surprising number of things in there. Always look, always dir your object, always help your object. Your object. What is your object? Always type your object. Know what your type of your object is. Is your object callable? Is it a callable object? There are different things you got to keep straight in your mind. Is an object iterable? Can you iterate the object? Does it have a length? Can you use the len function around it? These are very Pythonic things. The len function is a built-in that lives in global. Take a look at global. When you start a notebook, before you do anything else, type in globals, open parenthesis, close parenthesis. Wait, what? Why not just the word globals without the open close parentheses? Well, because globals is a callable. Globals is a function. The output of the globals function is a dictionary. You should look at the globals dictionary. You should look at the globals dictionary before much goes on in your notebook. Right when you restart the kernel, look at globals. globals, open parenthesis, close parenthesis. Is callable? Is there an is callable function? Yes, somewhere there's is callable. I know I use is callable. I probably import it from something like collections or functions. I think there's a functions collections. There's a collections collection. There's a lot of places you can import stuff from that does all the most common stuff you'll encounter in Python. Most of the beaten paths are in the standard library under names you would not expect. Concepts that are surprisingly useful are there that you don't know are there, and you wouldn't know to look for them. But the most Pythonic way of doing a thing might, for example, be using a named tuple, which you import from collections. From collections, import named tuple. Unlike most things in Python, you are forced into some tiny bit of object-oriented thinking with named tuples, but it's a tolerable amount. You have to create a factory class, which is less intimidating than it sounds. Once you, from collections, import named tuple, you say rec, R-E-C, capital R, lowercase e-c for record. Rec, capital R, lowercase e-c, equals name tuple, open parenthesis. Argument's a bit strange. Quote for string. Uppercase R, lowercase ec. In other words, what you just have as the name outside, but it's also inside this string. Close quote, comma, open quote again, word, space, word, space, word, space, word, close quote, close parenthesis. Each word being a label for your name tuple. So one word might be X, one word might be Y, one word might be Z, in which case you're making an XYZ coordinate name tuple. Why? Because square bracket notation to get to values inside objects is tedious. So if you use dictionaries to set values and you say, here's a dictionary, and it'll be a bundle of name value attributes. One name is X, its value is the X of, the spatial coordinate, the actual number. Y is a key in the key value, another key in the key value of that same dictionary, and then finally Z. Now, a couple of things. You've used your X, Y, and Z position in that dictionary. So you're now going to have a list of dictionaries, and dictionaries can have any number of name value pairs, and you don't need that kind of flexibility. You don't need the flexibility of a dictionary with all that fast lookup speed. All that fast lookup speed of a dictionary is the overhead that like lists have for being dynamic, to be able to append to lists and to pop things off of a list. So if you want labels and positions and fixed positions without the overhead of a dictionary, you want a name tuple. A name tuple can have an X, Y, and Z position inside of it. So parenthesis, number, comma, number, comma, number. But because it's not just parentheses containing those numbers, but the word REC at the front of it, uppercase R, lowercase ec, open parenthesis, number, comma, number, comma, number, close parenthesis. Now, if you set something equal to that, so if not X, we're going to use X. If you set chord, lowercase C-O-R-D, because it's a single coordinate equals an instance of this name tuple stamped out by your factory class. Now you can do chord.x to get the X value, chord.y to get the Y value, chord.z to get the Z value, which is a heck of a lot easier than it being expressed as a dictionary, where it would be chord, open square bracket, quote, X, close quote, close square bracket. So by using a name tuple, you just get rid of the open square bracket, the quote, the close quote, the close square bracket, 4 whole characters that are frankly quite tedious to look at, when chord.x could have done the exact same thing, named tuples. Named tuples are good. So, named tuples come into an API in weird places. Sometimes you're using them without even knowing it, because someone who's returning values from something to you will often like to do it as a name tuple, because when you inspect that object, you go, oh, here's a bunch of positions with labels. I'll grab the things in this labeled position, and there's the value. And you don't even know you're using a name tuple, and you're using a name tuple. I guess, kind of like the way the requests response object works, because it's response.text, response.status _ code, right? That's object-oriented addressing. So you get to use the convenience of object-oriented addressing, this dot that, without the square brackets and quotes, without all the overhead of classes and selfs and init functions. There's a lot of really weird Pythonese. I don't even want to call it Pythonic, because Pythonic implies a sort of badass, right? There's the Pythonic way of doing things. And it's usually a lot of fun coming up with the most Pythonic way of doing things, which increasingly is involving list comprehensions and the context manager. So I was just describing to you persistent dictionaries by use of SQL DICT, which is part of, a pip install SQLite DICT, because certain things is surprisingly not in the standard library. So when learning Python, learn the standard library first, but before even the standard library, crawl before you can walk. Don't bite off more than you can chew. Look at globals. Look at the globals dictionary. And what else? What else? Globals plus what else? Built-ins. All things in globals are built-ins. If you look at the type of things you find in global, you'll see the word built-in. Len is built-in. Len is different from many other things in Python. As long as an object is iterable, you can get its length. What is iterable? Iterable means it has sequences in it, and you can do for each loops on it. For each, does it have to be the word each? No, it can be for item, it can be for foo. You have to understand where things are arbitrary and how Python people are not going to appreciate that real big tripping point that noobs are going to be encountered. Be sympathetic that for loops are not intuitive. For arbitrary name in not so arbitrary thing, which is iterable. It can only be in that third position in that deal, for item in fourth position, because in has to be counted, I guess. So, for item in iterable, right? That for item initerable. That fourth thing has to be an iterable thing. So it has to be a list, it has to be a tuple, it has to be a dictionary, it can be a name tuple, it can be an ordered dictionary, it can be a whole bunch of different things in Python. So what about this with open or with SQL as? Well, is that a loop? Not really, but it can produce an iterable because that as, that file handle, is going to probably be iterable. So you can usually do for key in DB, and I almost always do for key in DB. And things start to have an inherently obvious truthiness about them. Like, of course, things should be written this way. For key in database. Duh! Now, for key in database, colon, because you must start a loop with a colon. So, that is where for item initerable and with open as come together. One of the most common things you do after a with open as or with SQL DICT as is for item in whatever you opened it as, DB, usually in my case lately. So fundamental, so like should be standard library, should be first thing everyone introduced to. So I guess I'll say it. How far are we into the video? We're 41 minutes, almost 42 minutes into the video. You can pip install MLSEO. You can pip install MLSEO. I am starting the Wonderland adventure of taking up the field of search engine optimization as a path onto Python, as a path onto Jupyter Labs standalone, as a path onto pandas, and as a path to more noble causes someday, hopefully, for you, because life should not begin and end at search engine optimization. It just happens to be that search engine optimization is a pure data field. It's the first of the hard sciences you can make a living on while your skills are all really purely software. Sure, you're dealing with hardware, but through these wonderful abstraction layers like with SQL DICT as DB. You're dealing with hardware. Psst, that opens a file on the hard drive and starts reading and writing. Wait, what? So where's all that complexity? That's why they call it the context manager. It's managing all that context. It's doing the open. It's doing the with finally. It's doing all the good principles that it used to push that complexity onto the person doing the coding who's like, whoa, wait, why should I remember that pattern every time? Shouldn't I just be able to indent a certain amount, and after I come out from that indent, everything that I explicitly want to make sure is done is explicitly done? Okay, it's implicit that it's getting done because the context manager implies that it's getting done, but quite explicitly. When you see with, you know that the housekeeping's being done and it's fairly safe, except in some cases where it's not, and you have to import a specific context manager to do a close on it. I'll get into that later. I found one edge case where the context manager couldn't fully clean up SQLite operations. So I'm finally taking up SQL again after like 10 years of being away from it. 15 years maybe. My whole career on Python has been an almost anti-career in SQL because I was on the Microsoft equivalent of the LAMP platform, which was IIS, Internet Information Server, plus some form of SQL Server, and of course running on the Windows operating system. And that's it. So IIS instead of Apache.